Hi, welcome back. Today we're going to be taking a look at the 2011 LaGrange problem. Now, this is the 2011 series and sequence question from the BC exam. And they gave us this function. They say f of x equals sine of x squared plus cosine of x. And they've given us here the graph. They tell us they give us the graph of the fifth derivative. That's what this means right here. So this kind of tells me that I'm probably going to be using Lagrange, error bound, or alternating series or some sort of thing. So we're going to need the fifth derivative. And they give us the graph of the function here, right here, and the fifth derivative. And oh my gosh, yes, there it is. It is the world famous word not function. I promise you, it's everywhere. So for part A, they want us to write the first four non-zero terms of the Taylor series. We see the word series here. We're going to need that plus dot 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 for sine of x about x equals 0. That's nice because this is telling us it's going to be a Maclaurin, so we can use our substitutions. We're going to use that to find sine of x squared. So let's go and do that. So that's pretty easy to do. Sine of x is an odd function, so it's going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. Now there's four terms plus dot dot dot. Next, we want sine of x squared. Well, all we're going to do now is everywhere we see an x, we're going to replace it with x squared. And this, of course, is going to become equal to x squared minus x to the 6 over 3 factorial plus x to the 10th, oops, that's a weird looking x, x to the 10th over 5 factorial minus x to the 14th over 7 factorial plus dot dot dot. So let's see how many points this would be worth. On the AP, that's worth 1, that's worth 2. So you got like 3 points already. How nice is that? All right, the next one for part B. Now for part B, it says, write the first four non-zero terms for the Taylor series. There's our word series again. So plus dot 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 for cosine of x around x equals 0. So cosine of x on x equals 0, so it's getting Maclaurin. So I'm going to go and do that. Cosine of x. Cosine's the even one, so it's 1 minus x squared over 2 factorial. I'm just writing out the Taylor series for cosine plus x to the 4th over 4 factorial minus x to the 6 over 6 factorial. And don't forget your plus dot dot dot. So now what they want us to do, they want us to write f of x now. So remember what f of x is. F of x is the sum of sine of x squared plus the cosine of x. And I'm going to go and write that. So I'm going to combine like terms here. So, but I'm going to go in order. So take a look here. If I look at x squared here, and there's cosine of x, I want to add those together. But we only want the first four terms. So I'm really looking at the degree. So let's look at the degrees here. Well, this has a degree of 0. And I have a degree of 2 here and a degree of 2 here. So that's my first two terms, the 0 degree and the second degree. So let's take a look at my third term would be. I have x to the 4th here. There is no x to the 4th here, so there's my third term. And then my fourth term will be the x to the 6's, but I got to combine those. We're going to do some mathematics to combine them. Hope you guys don't mind, okay? I'm going to do some shortcuts here. But you can check the math if you need to. Oh, hello, little rabbit. I'm outside and I saw a little rabbit. All right, so when I combine them, we're going to get 1. Whoops, hello. We're going to get 1 plus x squared minus x squared over 2 factorial plus the x to the 4th over 4 factorial. And now we're going to do with the x to the 6's. So I got minus x to the 6th over 6 factorial minus x to the 6 over 3 factorial right here plus dot dot dot. Now if you simplify it, what you wind up is the following. I'm just going to simplify it for you. We get x plus x squared over 2 plus x to the 4th over 4 factorial. And when we combine those two, we're going to get minus 121 x to the 6th over 6 factorial. Just trust me, that's what it equals. So when you add these all up for the points, you're going to get 1 point here and 2 points here. Although, to be completely honest, on the AP, you should be okay with leaving it like right here. You should be okay with that. You shouldn't have to simplify it. unless we need it later on, which I don't think we do in this problem. All right, so let's go and take a look here. Now, for part C, we want to find the value of 6 of 0, of the value of the function of the 6th derivative at 0 now. So, yeah, we would need it to simplify this. How awful is that? So for part C, we've done lots of these before. Oops, hello here. Let me put this back in the wrong color. Okay, let's take a look here. So for part C, we want the value of the 6th derivative. Well, this is from Taylor. So in Taylor, we are saying that the value of the 6th derivative at some center over 6 factorial x to the 6th has to equal what it's going to generate. So this right here is just my Taylor polynomial rule that we've been talking about. And we're going to set that equal to what it equals in the actual polynomial. That's just negative 121 x to the 6 over 6 factorial. So this is going to equal negative 121 x to the 6 over 6 factorial. And if you notice, quite a few things cancel out. These are going to cancel out. The x to the 6 cancels out. So therefore, the value of the 6th derivative is just negative 121. And it's not going to be worth much. It's only worth 1 point. Not worth too much. But take a look already. We've got 1, 2, 3, 4, 5, 6, 7 points. There's only like 3 left. And now comes LaGrange. All right, so let's take a look here. So here we go. D. Let P4 of x, so the 4th degree Taylor polynomial for f about x equals 0. So take a look. We're looking at only a 4th degree Taylor polynomial. So take a look here about f. So if we look at our f right here, there's f of x, our 4th degree Taylor. So we're only going to here, right there, okay? Using the information from the graph above, the 5th degree, show that the value of the 4th derivative minus the approximate value, or whatever, approximate minus the actual value, is less than 3,000. So this right here is our error problem. So let's talk about the error. When we are looking at error, there are 2 ways we can do it. 1, alternating series. 2, LaGrange. That's all we know. That's the only type of error that we know. So we take a look. Is this an alternating series? If we look here, if we look at f, it is not alternating. So we're not going to use the alternating series, so this is LaGrange. So let's take a look at what LaGrange needs. LaGrange needs the maximum possible value of the next derivative. Right there. It needs the maximum possible value. So let's take a look at the graph up here again. Now, we are having an x value of 1/4. So we want the maximum possible value of the 5th derivative at x equals 1/4. So that's what we're looking for right here. And if we go back up to our graph, here is 0, there's 1, here's 0, and x equals 1. Well, 1/4 is right here. So if I look at my graph, there's 1/4. Here is the value of the function. Here's the value of it, but I really don't know what that value is. I mean, I could probably estimate it at 35, but do I know for a fact it's going to be 35? And of course, the answer is no. So what I'm going to do is I'm going to look at, well, what's the maximum possible value that I know it could be? So, and I'm going to go up to the nearest tick mark, which is at 40. So I am going to say that the maximum value of the 5th derivative of x is 40. And you might be thinking, yo, can't I make it 60? Or what about even making it 80? Or 120? And you're right, we could use these as a maximum, but we want to minimize our error. So I'm going to pick the one that is the maximum value that I know, but that is also closest to the actual value, and that's going to be 40. So we're not going to pick 60 or 50 or 80 or any of those, because I'm only going to use one that I know for a fact is closest to the actual value. So here's what we're going to say. We are going to say, and you might remember the notation, that the maximum value of z of the fifth derivative at x equals 1/4 is 40. Therefore, we can say that the error, and I'm going to use zero notation again. I'm going to use zero notation. So I'm going to say that the error, that the error, p sub 4 of 1/4, of our polynomial approximation minus the actual value, the error is less than or equal to the next term. Remember, we want the next term. Now be careful, we are using a fifth derivative. So we're using a fifth derivative, so we're not going to use this. We're actually going to use the x to the fifth one. Okay, so that's going to become, so our Taylor is going to be this, the 40 over 5 factorial for the fifth derivative times x to the fifth, which is 1/4 to the fifth. You don't have to simplify that, which is less than 1 over 3,000 by LaGrange error bound. Okay, so how could we shortcut this a little bit? You could be able to get away with what we've been doing here, writing out the word error here, or writing R4 like that. You can get away with that as well. Okay, and there we go. But you should mention somewhere that the maximum error, and that's what the C means right here. Okay, you want to write something where the maximum error at 1/4 is 40. You should indicate that, and this will be worth 2 points. All right. Hope you guys enjoyed the video. I will see. Whoops. What happened there? I will see you all later. Thank you. Bye bye.